Okay, students. I announced in the morning to girls, but again we are back to the normalcy. So sixth period we are having 3 days for maths, Monday, Wednesday, Friday, which is exclusively for IIT, but we take as per our requirement. Okay, we'll cover it as per that. Earlier also we used to have 3 days, but at that time it will come at a stage. Now alternate days are coming, and other 3 days I will go to 12. Okay, same case. Now we'll continue with the part of the next conic, which is the ellipse. And I have been sending the videos. I think if you go through them, it is very easy to follow my lesson, which is continuous with that. Make it as a habit of going to that videos, and then you can do the NCRT part of 8 point, I think 11.2 from this one parabola part. Easily you can do very basic questions only there are. There is no deeper questions from NCRT for conic sections. Now we will come into the part of ellipse. Already you know the shape of ellipse. Yes, that is extended circle. Ellipse is nothing but stretched circle. Yes. So this way, this is the shape of the ellipse. All the planetary orbits here in the elliptical orbit. Planetary motion, yes. Everything you know, Kepler's laws, all those. Now going to the detail in terms of malleable part, how this ellipse will come. If beta is greater than alpha, yes, then ellipse will come. Beta already you know angle with respect to surface to the what you can say axis, that is angle, and alpha is generator with axis. Beta is greater than alpha, and beta is equal to 90 degrees. Special case of ellipse is nothing but circle. That also we'll discuss now. Once we know ellipse, then we'll understand the part of circle. Very easy, because a circle is a change in what you can say deformity. If I stretch this way, what happens? Yes. And I stretch this way, becomes ellipse. So in this way you understand it. Are you clear? If you stretch both sides to contract this circle, ellipse becomes to circle. And you stretch the circle at one end, both sides in the horizontal way, it become ellipse. So both are mostly and closely related with the condition. Beta greater than alpha, ellipse will come, and this is the conic. And we'll define again, we take the standard equation log, how we have done in the case of parabola. 4 types of parabola, y square equal to 4x, y square equal to minus 4x, x square equal to 4ay, x square equal to minus 4ay. We have learned how it comes. Same way we derive here also, but here we will not get 4 ellipse, 2 types of ellipse. One is symmetric to x-axis, and another is symmetric to y-axis. Similarly, hyperbola also symmetric to x-axis, symmetric to y-axis, because this is a closed curve. And circle is symmetric to 4 axis. It is only one, and it is a special case. How do we know something about circle? But we generate the equation of circle in terms of conic. That also we discuss about. Before going to circle, we discuss about the ellipse. Then how this comes already you know, beta greater than alpha, and beta is equal to 90 degrees, you will get circle. That is a special case. Okay, it is always greater than alpha. Next, how it comes, you see, this how you define this as a conic or as a two-dimensional curve, right? So you can see there is a point, or you know this part, and there is another point. We call them as focus. So focus each is called the coordinates foci, the foci. Focus, or foci or foci. Yes, there are the 2 points. See here. Now, suppose I am taking a point in between them. In between is not exactly between them, some distance to them. So that the distance with F1 and the point distance, this is something you take P. So F1P plus F2P is equal to something I take constant, something alpha. Similarly, I take some point Q. Now F1Q plus F2Q is also equal to alpha. The value is fixed, and I am taking a point R. So that F1R plus F2R is also constant. Distance of some, see from the point, I am taking the points of the conic on the ellipse. The points lying on the ellipse should be defined properly. That from the point, any point, the sum of distances to 2 fixed points. What are 2 fixed points? Foci. Okay, there are 2 fixed points instead of 1 fixed point. For a circle, center is 1 fixed point. Like that in an ellipse, there are 2 fixed points. such that from the point what is taken, which is lying on the ellipse. Okay, the sum of distances from the point to the two fixed points is always a constant. Then, and I take another point here, yes. So the F1s plus F2s also constant, sum of distances. Now, if I am joining all these points, including F passing through, it cannot be any point. Okay, and like this, still it can be extended. Are you getting it? And this shape is nothing but the ellipse. So ellipse is the, again I am referring clearly, ellipse is the set of points whose distances from itself to the fixed points, sum of distances from itself to the fixed points is always a constant. All such points whose sum of distances from the fixed two points is constant are what you can say connected or joined to form the conic, which is called ellipse. Are you clear? Okay, so every point lying on the ellipse should satisfy the condition that its distance from one fixed point and sum of its distance from other fixed point is always constant with other fixed points. Are you clear? Such conic or the curve is called the ellipse. Are you clear now, ellipse? Similarly, parabola, what I told you, a fixed, there are set of points which is equidistant to a fixed point and to a fixed line. That is what I told you. The fixed line is called the generator or directrix, and the fixed point is nothing but focus. So P is a point, P of is equal to PM. If such way I take the points, all the points formed is called a parabola. And according to location, always I told you, parabola can be located right side, left side, upward and downward. Similarly, the ellipse also fixed, that standard ellipse. We are discussing only some part of the coin, not the whole. Okay, what is that? The center of the ellipse. Means center means you take a line, you take this way, you take this horizontal line. In between the midpoint will come, right? This is called center of ellipse. Okay, center falls as the origin. That is called the standard ellipse. What will be? This is origin. Are you getting it? What I am saying?
Yes.
So we say there are cases in higher engineering, higher mathematics research level where this is not a origin of your axis. We are discussing only special case which is easier case, that the center of the ellipse lies on the origin. Similarly, parabola also we discussed. If I type the parabola, I told you, this is always origin. Yes or not? And this distance will be A, this also A, and total distance is 2A. Likewise, this is 2A, this is also 2A. We took like that. That only 4A will come. And that will let us vector. That only we did now. So same way, we are taking here the ellipse also as a standard form such that the center of the ellipse lie as the origin, and through the center of the ellipse both the axes x and y will pass. Because in a graph, origin means both x axis and y axis will intersect. That only called origin. Yes or not? So we take this as x axis and this as y axis. Already you know this y dash, this is x dash. Now clear? Now see this. Now this is ellipse centered at the origin. Yes, and at the two foci or foci is called F1, F2. Called as right fixed points, and any point here already know P1 plus P2 is constant. Here if I take any point, you can take all. Now what is by your understanding? The ellipse is symmetric to x axis or not? Is it standing on x axis or not? Yes? How? I will tell you here. If I take like this ellipse is symmetric to y axis. Is it not? The major axis, how do you know, sir, what is symmetric? This is called this distance is called the major axis. Means this length is bigger, and this distance is called the no. This is semi-major axis, and this distance I am told. This is minor axis. Are you clear? Now see why I told major axis, because this distance is bigger than this distance automatically. So x-axis, the foci lies on x-axis, that the ellipse is symmetric to x-axis. Here you see here the foci are like this. Okay, here foci lies on y-axis, and this is called the major axis. Here major axis is y-axis, along y-axis. Yes or not? And this is minor axis, x-axis. Minor axis, x-axis here. Here major axis is y, but in this case major axis is x, minor axis is y. So this is called ellipse symmetric to x-axis. This is ellipse symmetric to x. Otherwise, where the foci lies on which axis, that is called symmetric to that axis. Foci lies on y-axis, the ellipse is symmetric to y-axis. Foci lies on x-axis, the ellipse is symmetric to x-axis. Are you clear? Where the foci lies, that ends are called the major axis. These two are major axis, and this is half exactly. So this is called the semi-major axis. So which is this is 2a and this is also a. This is 2b, this is also b. Are you clear? And this between these two, this is c. Are you clear? So center to focus is c. Yes, center to end point is a, and center to other end point is towards y-axis. Are you clear, ABC? C is center to foci, one of the foci, and this is A, this is C, and this is B. Are you clear, ABC? Small ABC, and they come in hyperbola also, remember it, always. ABC will be the ellipse and hyperbola. Okay, I'll make it sir. This is B, this is A, and this is focus now. This is C. Okay, that's why it is semi-major. This is also A1 automatically, right? This is also B1, and this is also C. Also clear? Not clear? Then I have to explain that one and two x. Otherwise, one side of the x. Major, semi-major. Half is same only, right? This is major axis up to here. Isn't it? This is semi-major. This is A, and this is C. This is B. If you listen carefully, you understand. It's not difficult. Small a, small b, small c is same because this is symmetric to both cases. This is A means this is also A, totally to A. This is B means this is also B, totally to B. This is C means this is also C, totally to C. F1 F2 is to C. Remember it. F1 F2 distance is equal to C. So you name this as A, B, C, D, something. AB is equal to 2A. CD is equal to 2B. I hope now you are clear. Yeah. It won't be more clear because it's a problem of the bakara or murga. Because it becomes so automatically. Okay, very clear? Now understand the small a, small b, small c. And now we'll discuss more properties related to this part. What is ellipse? We understand the components now, parts, all those. And this is conic. And I told you, it is used in space, dimension, engineering, everywhere. Integration, calculus. You will not be able to explore all the possibilities of why you are using it. When you go to 12, it will be more and more. If you go higher and higher, it will be continuous. So you must know that all the celestial, spatial, and the paths of moving or engineering, what you can say, objects will follow these conic sections, definitely. Now see here, ellipses are basically with respect to two axes, x and y. You understood now? Depending upon the major axis and the foci lying on which axis, that is symmetric to that axis. Now we should know relation between ABC and what is the eccentricity. One more word will come, eccentricity. That also will come in parabola also. C by A. Yes, again, ladder spectrum, that also we discuss now in detail. It is more into theory. When you go higher in maths, it will be more theoretical and applies to problems. Okay. Are you clear with this part? Let us start with the ellipse symmetric x-axis. Then we will move to the continuity of y-axis. Easy one. Like how it right hand parabola. To discuss one case, we start with the ellipse with the symmetric to x-axis. I took P as a point on the ellipse x and y. Okay. P x y is a point. Later we'll see. First we'll see the distance. Now I want to find AB distance. Okay. And this is C. You know it. And this is A. And this is B. Are you clear? Yes. C is the center to the foci distance. A is the length of semi-major axis. I have to write working also, but that's why I don't here. I have to derive the things now from here. Not able to see here. Then come this side now. Why come this side, both of you. You are going that side means how it can be. What should be there. So I have to write here. That's why I have to call it. Without center, I did not call it. You also have to. Can you see? Now see here. Okay. Now, are you clear with A, C, and B? B is called the semi-minor axis. A is called the semi-major axis. C is the semi-distance of foci. Semi-focal distance. Semi-focal distance. F and F is focal distance, na? Semi-focal, right? Now, this is called O or origin. Always I told you, our ellipse or conics are centered with the origin. So, center of the ellipse is nothing but origin of the axis. Both axis, x-axis and y-axis, will pass through it. Are you clear with this part? Now, this is x, x dash, y, y dash. You know this part. You know this side is left negative, that side right side positive, upwards positive, downwards negative. How do you know this part? Right? Now, I want to know the length of AB. Okay, so AB distance. A and B are lying on the point, 9 points on the ellipse of the asana. A is also point on ellipse, B is also point on ellipse. How I get AB value? Tell me. A F2 plus B F2. Can I take like that? A F2 plus B F2 is AB only, na? See, upper F2 there, that side. I took F2 that side. What is A F2? Tell me. This is C, right? And this is how much? This is A, this is C. So this is A minus C only, na?
Yes.
So otherwise A F2 is nothing but here up to here A plus C. Yes? A plus C plus B F2. How I take with this distance? This distance how I take? C. This is A minus C. So what do you call A is equal to 2 here only, na? Same only, na? A is equal to A. Same. Now I want to take the relation. Let me take a point here, something. Yeah. You take out this part. L is also lying on the ellipse or not? L is lying on the ellipse or not?
Yes.
Now, the distance of the point L with respect to F1, F2 is equal to A1 again. Because see here, F1A plus F1B is equal to 2A. I can take AB. AB is nothing but F1A plus F1B. Yes or not? A with F1, A with F2. Otherwise, AF1 plus AF2. Sum of distances. AF1 plus what you can say with A F1 F2 AF2. Because any point lying on ellipse, sum of distance from two foci is constant or not. So can I take AF1 plus AF2 is equal to constant or A or not? AF1 plus AF2 is equal to A or not? See, AF1 is nothing but A minus C. AF2 is equal to A plus C. Yes. So A is a point lying on the ellipse. So what is the condition of ellipse only? Any point on the ellipse, sum of distances is a constant. Similarly, B also same way you take. Now BF1 plus BF2 to take here. BF1 is equal to this is A plus C. Right or not? Yes. BF2 this is A minus C. So every point lying on the ellipse, its sum of distance at the focus is 2A only, no? Yes. Like that C also I can take, L also I can take or not? I took L on the ellipse. So LF1 plus LF2 is also 2A only, no? Yes. Because L also lying on the ellipse only, no? Because A lying on the ellipse, you got 2A. AF1 plus AF2. B lying on the ellipse, BF1 plus BF2 also 2A, I got that. Right? Similarly, L lying on the ellipse, LF1 plus LF2 is equal to constant. Because why we are saying A, B, L are lying on the ellipse? The ellipse defined is like that only. Na? Sum of point distance from two foci is constant. All such points are taken. I need not say each one of you are 11th maths, I got comic 62, 3 Vaishnavi, or other girl. Why? All of you are 11th only. What are you right? Sanya, I forgot to get name. Okay. In the way, if L is a point on the ellipse, A is a point on the ellipse, B is a point on the ellipse, anyway, the sum of distances from the point to two foci is constant. Once it was found 2A, with L also F1 plus F2 is 2A only. LF1 plus LF2 is equal to A only. Are you clear? Now see here. How LF1 can be taken? Tell me. This is the hypotenuse for this right angle. Because axes are perpendicular, you know it. This is C, this is B. What is LF1? Tell me now. Yes, B square plus C square are not 2 power. This is C, this is B. What about LF1? Yes. Now LF2 again C B. So LF2 also same only na? Now LF1 plus LF2 what comes? Tell me 2 root B square plus C square is equal to 2A. Now square both sides. A square is equal to B square plus C square. Or C square is equal to A square minus B square. Anyway, you can take rest. And ellipse, remember this formula between A, B, C. A square is equal to B square plus C square. You understand how it comes? Yes. Are you clear? Now we are going to get one more word which is called eccentricity. What is that? E. Eccentricity. What is that? Eccentricity. X. Eccentricity. Eccentricity is that it is the degree of the stretchiness. Degree of stretchiness. Degree of stretchiness means how it comes to know stretches. This is nothing but C by A. E is equal to C by A. So C is this and A is this. How much stretched? C, this is the original. It was stretched. Okay. So this is degree of stretching is C by A, which is called eccentricity. Now C is smaller than A or not in the case of ellipse? Yes. So numerator is less than denominator. So what is the value of E for ellipse? Less than 1. Are you clear? In the case of parabola, E is equal to 1 C by A because C and E are same one because this is circular only. This distance all are equal. Parabola E is equal to 1. We will get hyperbola next. Then E is less than 1 in that case. Okay. Now you got it. Eccentricity understood. C by A. What happened? I have sent already this part. Right? Are you clear till now? These are derivation part only. You need not remember, but you should remember these formulae. A square equal B square. How it comes, you understand enough. Only remember the formula. Derivation I am explaining now. Are you clear? Can I read this part till now? Can I read this part? It is there in the textbook also already for you.